Oh yeah, let's talk about this one.
Yeah.
Oh yeah, this now look.
There's something that you can. I don't know
turn
whether
this off here, hold on.
whether the camera will pick it up.
This Farhan is, you can put it right on top there.
Yeah. Okay.
See if it'll pick it up. Because this is what Farhan is going to present at FDIM later this week. Let me make sure it's on camera here.
Okay.
Hold on, let me aim it down here. Look at this. This is a magnificent device.
And you know, there is one thing which I'm very proud of in this, which is if you see here, okay, I have actually put SMD capacitors in an ugly way. You can hardly see them, right? So
We got to tell them what this thing is. This is the new device. Tell us about the new device.
Okay, so this is a reboot of the original BITX, not the micro BITX, but the original BITX, which was about 20 years ago, right?
And I have several of them.
Yeah. And we've simplified this design, and I've also evolved this design, right? So this one is a 2-meter version, and this actually scales from 160 meters to 2 meters.
But this is the 2-meter version.
Yeah, this is the 2-meter version, right? Actually, if you have a 12-volt supply,
let's see,
or a 9-volt, if you can, dial it down to 9 volts.
I've got 9 volts.
But do you have a DC connector?
Let's see, a DC connector. I could take one here. Oh, wait a second. Well, we had one from the.
Yeah. No.
No, I don't want to.
There's an easier way to do it.
I don't want to blow up your device on the way to FDIM.
That's fine. You can just clip it here, the 12 volts, and I can put that. Or we can just clip it there, right?
All right, you can just put it like this. I'll put this to ground.
Yeah, and the other can come here.
Just put it where you want it.
Yeah.
And I've got 9 volts on here now, but I could crank it up a little bit if you want.
Yeah, 9's good.
9 volts there.
Right. Okay. Oops.
Careful.
Yeah. Okay.
There it is.
Yeah.
All right, so it's got an OLED. Look at the OLED display.
Yeah, it's got an OLED display here.
Look at that, 145.900. I'm gonna make sure this is getting captured on the camera here.
It is. You can
You can see it. There we go. All right, good.
Okay.
Look at that.
Yeah. So what I've done here is 2 or 3 neat things. One is that you see that this is on 2 boards, right?
Right.
So this board is the basic radio, and you can swap these boards. In fact, a good idea would be to build multiple of these boards, which can go from 70 centimeters to whichever other band you want. Right? Okay. And on this board, on the back of this board is a Raspberry Pico. All right. So the Raspberry Pico controls the display here, as well as the SI570. And the reason why we do SI570, and let me just show this to you. Hang on. So you can probably see the SI570. Let me actually put this on, that way. So the SI570 is somewhere here, right? And you can actually hand solder it.
All right, hold on, let me see it. I can see it.
That one?
Yeah, I see it. Okay, good.
Right?
Yeah.
And it's a far better chip, by the way. Very good phase noise. It costs about $8, but nothing else. I mean, it's fairly simple to use, and you can probably see this underneath here. Let me just see if I can show you. Yeah, there's the Raspberry Pico.
There it is.
Which actually, you can program from here. So the Raspberry Pico is firstly a 32-bit processor, right? So you have a lot of, unlike Arduino, where you're always thinking of running out of memory, you don't have to do that. And the best part about it for people who do not like microcontrollers is you don't need to learn Arduino. To program this, all you do is you take the program file and just copy it over to the Raspberry Pico. Just plug it into your PC, and it comes as a USB drive, and just move the file over. That's all, right? Anyway, but there's been a significant simplification of this, and probably we can pull out the circuit and show. There's just one RF amplifier in the entire circuit. Okay. So this is the mixer, the front end mixer. And from there, we go to a 1 transistor IF amplifier.
Hold on, I'll try to pull up a circuit for you here.
Yeah. Okay. So here, just pull out the circuit itself. This is really my favorite Dilbert thing, So it says, Dogbird, look, I got the first video phone in the city. then he says, now we wait for someone else to buy a compatible video phone to call us. Right? And the Dogbird says the amazing thing is that the society couldn't advance without people like you.
Well, one of my favorite Dilberts is he's
about the knack.
No, the knack, but he's met a new girl.
Okay.
And he says to her, "Would my sex appeal be improved if you knew that I was a licensed radio amateur? How much?" And she says, 17.5%. And he says, "Ooh, goosebumps."
But this is the typical dilemma of VHF homebrewers, that who do you talk to?
Oh, I know, because I was showing you my hex beam before, and I said, it has a position for a 6-meter antenna, and I didn't even put it on there because, in my experience, it's like the white noise generator.
But this is the thing, the sunspot is really up there, and the band's opened up. Right. So that's actually one of the key things. You can do a lot of DXing now on VHF.
I know you told me a long time ago you were thinking about going to VHF.
Right. The other is that there are so many satellites now. There are a lot of big birds in the sky.
All right.
And the most important thing is, for $5 you can put an antenna farm into your windowsill with VHF. So
I know,
especially for people with HOA. Okay, so. This is the original BITX, right? But here you can see that there's one RF amplifier here, the second and the third. I mean,
that's really the original. That's before you even modified that second IF amp. You put a second transistor in there. Yeah. Right. I mean, I built one of these, and also you have only one diode ring, I think.
And both here. Actually, this is not a doubly balanced.
Right, because you put the second transformer in there in a later design.
So
by the way, Pete and I were joking about. We were going to get tattoos because I think this was from the previous April 1st. So we found a new thing called RF Tatts.
Okay.
We got tattoos. And Pete was going to get the wiring diagram for an SI5351.
Okay.
And I think I said I wanted to get the BITX20 on my whole back, this whole schematic of the BITX20.
So this is the original one, right? That is, you have a bandpass filter, RF amplifier, mixer, IF amplifier, crystal filter, then another IF amplifier, etc. So I don't know whether you use this Cascade tool at all.
I have tried. But I know that you're a big supporter, and for that reason I'm trying even more.
So the calculations showed that this has a two-tone dynamic range of 88 dB, which is what the ARRL reported as well in the review of MicroBITX, right? And noise figure of 10. But the thing is that if you see here, right, you have this RF amplifier, one IF amplifier, second IF, there's actually too much gain here. And even if you reduce it down to, the other problem here was, there are a couple of problems with this, right? They're just two tuned circuits here. I mean, in this one I added 3, but we started with 2. This is singly balanced.
Well, Farhan, this is an important point because you and I talked about this, and because I know that you've been recently a big user of Cascade and similar programs. And I remember asking you, I said, now when you did your original rigs, because the BITX20 goes back to what?
For 20 years.
20 years. I said, were you doing this? And you honestly told me, no.
No, not at all. Not at all. For example, I didn't design this. I just built it and it worked and I left it out.
And people all over the world did it too.
Because we had no idea what we were doing here. If you look at these inductors, I was just putting, as many turns as I could on these tap washers to, just get it to resonate.
Well, I got to tell you, I noticed a little bit of this when I built the 40-meter version of the BITX. I called it the Digitia. And I built it, and I built far too much RF gain into it. So under normal circumstances, it would work okay. However, if there was a CW contest,
it would just overload.
Even if I was up in the SSB portion of the band, I would be listening to CW because it's being overloaded because there's too much RF gain.
And the thing was that these transistors weren't biased for good signal handling at all. Right? I mean, at that time, I just wanted to eliminate as many inductors as I could because, just
inductors are problems.
Too lazy. As a result, when you put up a resistor, there's a voltage drop across the resistor. So the bias power of each transistor comes down. From here, we went to something which is this, right? So you have the bandpass filter, doubly balanced mixer now, IF amplifier followed by crystal filter directly going into the product detector.
There you go. Yeah.
Right. I mean, so it's actually a much simpler design.
Right.
Right. It's simpler. Yet, if you look at the
only thing is that when you have coming out of that crystal filter,
yeah.
You're going into double barrel mixer. There's an advantage of having a TIA amp there, right?
Yeah,
because you're able to set the output
right.
impedance on the crystal
exactly.
filter.
So if once I simulated this, actually you look at the dynamic range, it's 96 dB because you've eliminated the extra gain which was overloading the receivers. Except that the signal noise, the noise figure has gone up to 15 dB, which is perfectly fine. I mean, you rarely require even 10 dB noise figure.
Because the external noise is overwhelming it.
Yeah. So, I'll skip forward. And this is the entire circuit diagram. Let me actually put this on full screen. How do you go full screen? Okay, whichever way. Okay, there you go.
Wow.
So it's actually pretty simple. This is the entire.
This is of the SBITX. Oh no, this is of the
this is a new BITX, right?
Yeah.
So you use an ADE1 mixer. And the reason why you use the ADE1 mixer is because you're now looking at even UHF, right? Out of exactly the same circuit.
I'll point out that Todd, K7TFC, mostly DIY RF, he has ADE1 mixers on little boards. Ready to go.
Oh, wow. Okay. And then we also have a Diplexer here. And the reason why we use a Diplexer is, and this is the IF amplifier, and this time I've actually switched to trifilar or bifilar coils here, is that what's coming out of here could also be UHF.
You know, we did a Diplexer. One of the complexities that we did with the direct conversion receiver in our efforts to knock down Radio Marti, we put a Diplexer, a simpler Diplexer after the diode ring, and we used the W7EL Roy Llewellyn's from the optimized transceiver. And people were not really believers, like, why are you doing this? And I told them, I said, try to do it with and without the Diplexer.
Exactly. That's when you know the difference.
And when you don't have the Diplexer in there, you're getting all kinds of AM breakthrough and all kinds of nonsense. You put the Diplexer in there, boom, it's gone.
Goes away. And actually, the reason is very simple. So from, let's say, if you were operating this at VHF, right? And you had something coming in at 144, and this, by the way, is a 27 megahertz SSB crystal filter. Okay, we'll come to that. It's a very interesting thing. So, and this is at about, whatever, 130 megahertz or so. Now the output here could even be at 300 megahertz because you're adding what's coming in and what's going here. It's the sum is in UHF.
Right.
If you do not terminate that properly,
it's going to come back in.
Right?
And you're going to have 300 megahertz going in the mix.
These guys are just 2 and 2 to 2s.
Right.
They don't even know what UHF is. I mean, they haven't stepped out of their pond yet. So what you do here is you put this inductor here, which prevents the UHF from coming in there. It's like a choke. Okay?
And it sends it to ground.
And you have another one. By the way, this
50 ohms.
circuit here is wrong here. This should have been 50 ohms with a very small capacitor so that the VHF UHF goes in there. Right. So that's terminated properly. Then you have this IF amplifier, and this is a 27 megahertz SSB filter. Okay. And what happens here is that, I mean, if you actually look at a ladder filter very closely, it's actually a low-pass filter. If you can imagine that these crystals are basically inductors, it's a low-pass filter. So the shape is not that. The shape is that.
Which is what you want.
So it's actually an LSB SSB filter.
Right.
Okay. So what you need to do is you need to always position your BFO on the other side, on the higher side.
So it'll produce LSB.
Yeah. Right.
Which is something that also happened in the micro BITX.
Right, exactly.
And you and I talked about this, that I think it always becomes USB, no matter what, even if on 40 meters. Just because of the mixing arrangement, it comes out.
Exactly. So depending on whether this is on the higher or the lower side of the RF frequency, it will flip the sideband accordingly. Right. And this is actually, again, a much simpler circuit of a BFO. Instead of 2 transistors, it's just 1 transistor because that's all you need.
That's right. Right?
And it gives the audio out, and the audio out, this is the TIA, audio TIA, which Wes,
Wes came up with recently. I mean, which is an amazing. And I think Todd is doing audio TIA boards.
Oh, really? He is?
Yeah.
Wow.
I think so.
Okay.
Mostly DIY RF.
And the mic amplifier here, again, for the BITX, if you look at the original BITX, it had a collector load of 1K, trying to feed into a 50 ohm diode mixer. So that's been changed to actually it's half of the TIA circuit. There's a 47 ohm resistor here, which fixes the impedance at about 50 ohms, which feeds to the diode ring mixer. That's actually an important thing there.
Yeah.
Right? So this is actually a far simpler version of the BITX, which performs even better, right?
It's like the BITX with an OLED, with a Raspberry Pi,
right? Yeah.
And with the knowledge that you gained from the BITX experience and the use of Cascade.
Yeah. So this is all there is now, and this is one board, right? I'll just show you that. So this entire thing comes up, just on this. On this board, right? It's a very small board. It can be actually made pretty small. It can even be made smaller. In fact, when I started building this, I thought I'll build it for an Altoid tin box. Yeah. But I didn't do that because it's the first time you're building it, right? You always build the first time to throw it away.
Right.
And then you again build it much more.
Yeah. Well, that's why I've ended up with 3 or 4 of these receivers.
Now, on VHF, what you do is now what's coming out here could be VHF, could be UHF. By the way, very interesting. The SI570 goes only to about 180 megahertz, but you can use this at 435, exactly the same circuit, because the third harmonic of this will mix in there.
Yeah.
So the AD1, and if you drive it hard, which is what we are doing here, can actually, produce up to even the fifth harmonic.
Wow.
So out of this, if you just put a filter for 800 megahertz, you'll also get an 800 megahertz output.
Wow.
Yeah.
All right.
And the thing is, how do you, what do you do there? So that's actually pretty simple. It's actually very simple. Okay, this is the core and all its ugly glory.
Point out the crystal filter, because I had a tough time seeing it. There you go.
And the thing is, if you, I don't know whether you can notice this. Okay, I've hand soldered SMD capacitors, which are like tombstoning there. They actually, soldered like this. So you put a drop of solder there, put the SMD capacitor like this, and then,
that's one of the best phrases out of the whole SMD world, tombstoning, because they look like tombstones.
Exactly. And there's a fatality to it. The moment you put the solder on, it sort of, goes up. It's dead. So you sort of give up and go to do something else. And this is this is the AD1 mixer. And I originally had an SMA connector here. And this is the Diplexer going to the IF amplifier, which is before the crystal filter, the detector, the audio circuitry here. So,
Farhan, you're once again moving ahead so fast.
Yeah.
I mean, I'm still working on micro BITXs,
right.
And a little bit of the daylight again. I like daylight again. Daylight again is more like my kind of thing.
Yeah.
But wow, this is really cool.
By the way, let me just go back to the circuit diagram again. There is something very simple that you can do, which is eliminate all this and just put a single FET Colpitts oscillator. And it's all analog.
Wow.
Yeah.
There you go.
Yeah.
Now you're talking.
Yeah. So, actually you'll have a radio with 1 VFO, 2, 3, 4, 5, 6, 7, 8.
What would the Colpitts, what frequency would have to be at?
Well, I mean, this is at 27.
Right.
You could scale it down to 5.
Right, yeah.
Put the Colpitts at 2 megahertz and you have a 7 megahertz.
But you couldn't do it at VHF because the Colpitts would have to be too high.
Yeah.
You might actually have to go with it.
With a Franklin. Right. So, on the power side, okay, this is the back of the same thing. So this is the top side and this is the back side, okay? Now there's something very interesting here, which is this guy here. You see that there's a small wire which goes from one side to another. Mm-hmm. This is how you eliminate the digital hash. You can't have the digital and the analog circuitry on the same ground. So you have to have it on different grounds. And you should have only a single point through which it goes in. It's what's called as a star, wiring for audio. In all audio, they don't use a ground plane. They use a star system.
This is something that came up
a
lot of times. Rick Campbell with the RF amplifiers, and it always confused me because I was so used to common just one ground.
Right.
but he would have a separate ground for the audio.
So, by the way, let me also show you this here. Where is this? Yeah. On the circuit diagram too, I have actually, this is one of those things that I should have mentioned in my write-up, but so you see here, the sort of ground that we are looking at here is very different from the ground here. And there is one point at which this ground and those grounds are connected together.
Yeah.
Right? Which is why I've put this into a box, that there's a completely different kind of ground there.
But ultimately they hook up together, right?
Yeah.
I mean, ultimately
at one point.
Yeah.
Just one point. And this, after this is the power chain, and the power chain is actually pretty simple. So I'm using these gimmicks, and these gimmicks are just like small transistors, except that they've got 4 leads coming out of it. So this is the triple tuned band pass filter.
Yeah.
And what I've done here is, what happens is on a 14 megahertz, let's say band pass filter, you require 2.2 PF.
Right.
So when you scale it to 144, which is about 10 times that frequency, you require 0.22 PF.
Gimmick? Do you go with the gimmick?
Yeah, gimmick way. Or you do a tap down. So this is like tapping down. Instead of an inductive tap down, it's a capacitive tap down.
Right.
So we're still using 2 point, and if you see this, it's got only 10 PF and 2.2 PF capacitors everywhere.
On the Franklin, a lot of the feedback capacitors are at 1 PF.
Yeah. So you can actually do this.
Yeah, you could do that, or the whole gimmick thing where you take 2 pieces of wire and put them together.
Yeah.
And a lot of people questioned the gimmick. They thought it just seems so strange. Well, you're actually making your own capacitors by twisting the amount of wire together. Yeah. And then you could clip it to reduce the capacitance. You clip
it. Actually, you do this clipping in a lot of places. For example, when you're making an L network for an end half wave.
Yeah.
So you don't get those capacitors which can handle very high voltages, because even at 5 volts, you're transforming it from 50 ohms to 5,000 ohms.
Right.
So your voltages are going to be 10 times as much, and you don't have those capacitors. So you just put a piece of coax, using that as a capacitor.
And you start clip it.
But this is the power amplifier. So there's a band pass filter, which is, the RF is coming in and out, and then you put 2 stages of this AG303, less than $1, 20 dB gain, from DC to 2 gigs.
I think Pete's been experimenting with mimics.
The trick is that you need to always put an attenuator there to provide robust termination at both ends. Otherwise, it will oscillate, because there's 40 dB of gain right here.
Right.
And up to 2 gigs. So you won't even know that it's oscillating, because you won't be able to see it. And then we have a power amplifier, which is exactly, what any other feedback amplifier looks like. And then the low pass filter. And what I also realized is, and on the receive side, you have something similar to this, a low noise amplifier, and back here, this actually gives you less than 5 dB of noise figure. It's actually very sensitive. It's so sensitive that on VHF, when I put the antenna, the noise goes up.
Wow.
But it's very simple, and I also figured, after measuring, that the regular relays, actually, they work at VHF pretty well. You don't require anything more complex. So when you build it, this is what it looks like. Just reduce this. Oops, sorry. What happened? Oh, right, okay.
Look at the size of it.
Yeah.
Wow.
So this is a triple tuned circuit, and here I scratched out 7 pads onto which you can see the the coupling capacitors across it, and the resonating capacitors from there to the ground, and you put these copper sheets between these two to prevent the coupling, and that's it.
This is fantastic, and it's such an approachable project for. You'd have to be a pretty skilled home brewer to do this. I mean, but I mean, it's doable.
It's very doable.
Yeah,
right? It's doable, and I didn't try optimizing for low power consumption or this and that, but a couple of other interesting things is that will work on 5 volts.
Yeah. Now let me ask you this: you built it quite small, and I know VHF size is important. Yeah. Could you build it on larger boards?
You could do that, provided you use these coaxes between those points. But if you see this looks pretty sloppy, right, from here to there. So there is a 0.01 microfarad capacitor which is coupling here. So this is the mimic the input is coming in here,
Yeah.
and on output, what you do is you put a resistor in series with an inductor, which is an odd thing for us HF people.
Right.
You do that because you do not want, firstly, the this is a 1 microhenry inductor. Okay, you do not want its Q to be very sharp so that it starts to oscillate anywhere, right? So those two are in series.
So you basically they're kind of swamping resistors on the inductor.
Series swamping, and also it provides the correct bias for the transistors inside that, right? Wow. So if you had not had the 100 ohms, then this transistor would blow because the biasing is internal to it. So there are two stages of that with a 6 dB pad, and here you can just use your regular capacitors and your regular resistors. You really don't have to bother with that. So at 2 meters, it's almost like HF.
Right. Wow.
And that's a low pass filter. As you can see, they are at right angles to each other because I didn't have space to put shields in there. I should have put in shields. Then what happened was that this was a longish stretch from there back to this is the receiver LNA here, going back here. So I actually soldered a small bit of RG 174.
Yeah. RG, that dielectric will melt really fast.
Yeah.
I'm going to give you some Teflon.
Yeah, actually, I couldn't locate the Teflon. It was lost in my junk box. Otherwise, usually what I do is I use Teflon because I just hate it. But what happens with the RG, 174 is when you're soldering the core, the shield starts to melt around it.
It starts to melt and then it shorts.
I just hate it.
I hate it too, and also I hate the Coax because it produces Murphy's whiskers and they pull around. But wow.
So actually, this was the most difficult part of making this because this SMA connectors pin is directly soldered to the pin of the relay.
Yeah.
Right, and I don't know whether you can notice it, but there's a small wire here which is actually connecting to the pin on the relay. And then I had this guy, okay? And this guy had to actually, this projects out from the from the box here. And you couldn't turn this, around so that the chassis of it, fits in here, right? This is where the box is. So I had to really push this thing through and,
What a beautiful piece of work. I predict an outbreak of VHF enthusiasm around Hyderabad and other parts of the world.
And there is something very interesting happening here if you see this. So this is the grounding, because what's happening here is that here when you make a bandpass filter like this, okay, there's also stray capacitance between this side and the back. So you can't leave it ungrounded, okay? So you have to actually put a ground, which is you keep drilling all these holes along here and then put small pieces of wire and solder both the sides together.
Yeah.
So I probably have it somewhere. Okay, that's what the mimic looks like, and you have to basically pull this. These are the input outputs, and this is the ground, and that goes in there.
Beautiful.
I don't know if I.
It looks like a cool project, but it looks like
this is how you started it.
Yeah, there's the board layout. Yeah.
So there are a lot of holes here, and you put these small eyelets kind of things, and then you solder them up on both sides.
Yeah.
So, VHF is very interesting, and the best part is you can carry it with you. You don't have to carry a big antenna with you. Let me see if I have. Oh, it's the same thing. Yeah. Okay. Anyhow, but that's the new project that I'm bringing to FTIM.
All right, I'm gonna hit this because I want to save. I want to make sure we save all this.
Yeah.